Hello, everyone. Today, we are going to talk about DeFi scams and how, with the power of symbolic execution, we can detect and expose them. Let's get started. My name is Alon. I'm the co-founder and CTO at Redefine. Redefine is a Web3 security company, specifically helping users and institutions to manage and mitigate risks, including DeFi scams and hacks. Prior to that, I worked for the Israeli government for many years, doing cybersecurity and crypto. We all love DeFi because it's a permissionless and trustless nature. But the trustless ain't always trustworthy because you depend on the security and the credibility of the smart contracts. Now, anyone can write smart contracts, even bad people. Over the past 3 years, more than $2 billion have been stolen in DeFi scams. There are more than 100,000 scam tokens. Most of them are traded on known dexes like Uniswap. Rug pull is the most common scam. It's when a scammer develops smart contracts with a backdoor, convinces user to buy it, and when the price goes up, suddenly he withdraws or pulls the rug out from under the investors, causing them to lose their investments. There are several types of such vectors like prevent selling, hidden mint, and forced transfer. We'll cover them all. What is symbolic execution? Symbolic execution is a software testing technique that uses symbolic inputs to analyze all the potential execution paths of a program. It is used to detect bugs, to verify the correctness of a program in code coverage and in security analysis. We will see how symbolic execution can help to detect DeFi scams. How does it work? Let's say we have a simple function with some computations and if statements. The first step is to replace the concrete inputs with symbolic inputs. The symbolic inputs can represent any given value, any possible value. In this example, A and B are symbolic inputs. Then we execute the program symbolically. Operations in the program that involve these symbolic inputs are carried out symbolically. In this example, Z equals 2 times Y, which translates to symbolic expression, Z equals 2 times B. The symbolic engines create symbolic inputs and gather path constraints. Path constraints are conditions derived from the if statement that the symbolic inputs must satisfy in order to follow a certain path. In this example, there are 3 possible paths, and at the end of each path, we can see what is the path constraints that define this path. The final step is to solve the model. We use constraint solver, also known as SMT, to find concrete inputs that satisfy the constraints. In this example, there are 2 solutions. Let's take, for example, one, A equals 2 and B equals 1. It means that if I put these inputs into this function, the function would follow this path. Sounds complicated? Let's try to explain it in a simple way. Imagine you are in a large maze full of twists, turns, and dead ends. Normally, you would have to go through the path, making decisions at every junction. And if you hit a dead end, you would have to go back. This is like traditional execution of a program. You give it inputs, and you see where you end up. Now, imagine that you have a magic bird's eye view of the maze. You can see all the possible paths at once. You can see where each junction will lead without having walking in this maze. This is like symbolic execution. You can see all the possible execution paths of a program at once. Let's see how symbolic execution can identify actually scam tokens. The ERC-20 standard only defines the interface of a smart contract token. And the functionality can be anything. So here we have 4 steps. The first one is to run the token smart contract symbolically, like we've seen before. Then we add constraints on important variables of the token smart contract, like balances, total supply, allowances. These variables plays essential role in the behavior of the smart contract, and we want to make sure the behavior is fair. By solving the model, we'll find concrete inputs that satisfy the constraints, and we will prove if the behavior of the token smart contract is fair or not. Let's see 2 examples. Who can mint my token? The risk with an uncontrolled minting is inflation, which can lead to drop in price. Here we see a real-world scam example where a scammer added a backdoor to the token smart contract with a functionality to be able to mint an infinite amount of tokens. To use symbolic execution, we should first define the constraints. The first constraint is increasing the total supply, which means the total supply at the end is greater than the total supply at start. The same as for the balance of the caller at the end should be greater than the balance of the holder at start. Now, minting can be legitimate, for example, in wrapped token and LP token. So we need to find a way to differentiate between legitimate and illegitimate minting. For that, we add another constraint, minting for free, which means the caller doesn't give any value in return for the minting. So we also define value equals 0 and allowance equals 0. By solving the model, we find that there is a specific input that satisfies the constraints that we defined earlier. There is a burn function, and if you give it a specific input, amount equals to 11, anyone can mint an unlimited amount of tokens. If you can see on the right, this is the source code of the scam smart contract token, and you can see that if b equals 11, it returns a big number, and the burn function uses this function. So actually, instead of burning tokens, it's minting tokens. The second example is who can steal my tokens. Let's define theft as a privileged caller who isn't the holder, can reduce the holder's balance without an approved allowance, without permission. So we define constraints. The caller shouldn't be the holder. The balance of the caller at the end is less than the balance of the caller at start. And the allowance equals 0, which means no permission has been given. By solving the model, we found that there is a function called approve with capital A, which isn't defined in the ERC-20 spec. Usually it's approved with lower a. And you can see here in the implementation of this function, the owner can set the balance of any holder, which means he can reduce his balance, which means he can steal his tokens. To summarize, there is a known phrase in crypto, don't trust, verify. Sometimes it's hard to do that. Even if you have the source code of the smart contract, sometimes the malicious functionality is hidden, and we've seen yesterday several examples of how can we trick the verification method of Etherscan. What if you don't have the source code? Symbolic execution can fill that gap. It runs on the bytecode of the smart contract and can prove if there is some functionality of the program, of the smart contract, that is unfair, that is a scam. It's a necessary tool across the board. Developers, auditors, security companies should use Symbolic Execution. At Redefine, we automated at scale. We provide due diligence API for users, for exchanges, for wallet providers. Recently, we announced the integration with Gnosis Safe, and every of their users can benefit from it. If you want to know more, please reach out. Thank you very much.
Thank you so much, Alon. This is great.